All right, so let's recall some integration. You guys remember this thing?
Yeah.
Yeah, maybe. Okay, so here's a function, here's some axes, here's an A and a B. What does Riemann integration look like?
Take a bunch of little slices and add them together.
Okay, which way does the slices go?
Let's go with the x-axis first.
Well, you're aided.
3D so Z.
Well, you put a C
Up
between
and
the A
down.
and the B.
Yeah, they kind of go up and down, right?
Yeah.
So I take a little, a little chunk here, and I'm going to do, for illustrative purposes, 3 little chunks, right? And we're going to say, okay, how wide are our little chunks?
Delta.
Ah, you guys have played this game.
We had to learn it very well.
Okay, so those guys are all delta x, right? And then maybe you make rectangles or something like this. How big is this rectangle?
Delta X by
Delta x by some height, right?
Yeah.
Okay, so that height here is f of, yeah, this is A, right? But f of something, right? And then like maybe there's a rectangle here that's not from one of the ends, it's from like that spot. How tall is that one? F of, yeah, some x thing, right? So if I was doing the left end point, it'd be A plus delta x, right? Yeah, I'm just gonna call it xi star, maybe, right? It's in the ith interval and it's special, so I give it a star, right? You guys remember doing this? That was kind of arbitrary.
Star, yeah.
Oh, you guys didn't do that?
No, not stars.
Okay, so you would have called this x2 or something?
X and
It was always nice.
Okay.
We rarely did more than one slice.
Rarely did.
Okay.
Just a representative slice.
And then like here, yeah, there's another one, and to
Yeah.
get this whole what? To get this whole what? What am I trying to do?
Get the area.
Area?
From A to B.
Okay, so we'd say, all right, the area is about,
F of
Isn't the integration?
Are you talking about the
Integral
integral?
A to B. No, integral.
okay, so I want to not, so if I want hard equals, I do an integral.
So then F.
From A to B of
Yeah.
f of x dx,
So
right?
approximately sigma then.
So approximately it's a sum, right?
Sigma I equals 1 to n.
I is 1 to maybe n, however many
F
bits
of
you're
X
splitting
and
it. So f of xi
Delta X.
star delta x, and delta x is,
Number of intervals.
b minus a divided by
N intervals.
n usually.
Yeah.
Cool.
Uh-huh.
Try to cut it into n equal pieces. Those pieces don't actually have to be equal size, but it's kind of easy if you think about them as equal size. Okay, so great. I got some recollection for what one-dimensional integration looks like.
Yeah.
Cool.
Uh-huh.
Any questions about how this thing works?
No.
Okay. Remind me, what happens if the function goes under the x-axis? So like if you had a function that did something like this,
Change.
here's your b, here's a.
That looks like.
You have to split up into.
Yeah, like
Yeah,
A
split
is
them
where
up
it
into
changes
two.
and then from where it changes to B.
Okay, you want to do this piece as 1 bit, right?
Where that center part is C.
Yeah, I'd say this bit's positive, right?
The other part's negative.
And the other part's negative. So if you don't make that split, right, you just get signed area, right?
Mhm.
Cool? All right, that's what I need you to know about one-dimensional integration.